Hi OSLO users. In this video, we're going to talk about vignetting factors and using Vig, which is a command that can be used to help set vignetting factors. So we'll use the demo triplet lens. These vignetting factors are really great to use when you have an off-axis bundle that's clipped by a surface. In other words, it's vignetted. There's a lot of reasons to do this in optical design. When you have these types of cases, it's efficient to scale the bundles for those off-axis points to take that clipping into account. In other words, why would you trace rays that never reach the image? So it's most useful when a system is vignetted. And there are some restrictions on its use, on the use of VIG specifically, that I will talk about. You'll want to change vignetting factors as you optimize or as the system changes, because if you set them with a certain amount of vignetting, at some point it might be that when you optimize, the system has changed around enough that you'll just want to reset it, but it's quick and easy to do. Keep in mind also how rays are being aimed through the system when you use VIG. It doesn't work with all types of ray aiming. It doesn't make sense to do it with all, and specifically the rim reference mode is another modality that does similar sorts of things as this that you'll want to use in different cases. I'll talk about that more in a moment. So the lens we're going to use for this is going to be the demo triplet. If you need to remember where to open that, it is actually in the EDU version under the wherever you're storing your private or your public directory. And so what we do here is I've got it open and you can see this off-axis bundle is clearly being clipped. What will be key in this is that the vignetting factors are going to be determined by the surfaces that you are using to check. So here we're checking on the very front surface and we're checking on this back surface, and some of the rays are clipped by the front, some of the rays are clipped by the back. If we take this, and I'm going to change the object point to a full object point, so that's the SOP command, just the fastest way I know to do that. And now if I plot the beam footprint, you can see we have the ray bundles that are being shown at the full field. Some are being vignetted here by the second surface. Those are the ones in the red. And then the ones that have already been clipped here were clipped by this front surface. For this off-axis bundle, essentially. This actually might be the -1 point. I can't remember. Anyway, so the key is part of them are being done by the top, part of them are being done by the bottom, and it's two different surfaces doing it in this specific case. Now, when we have this situation, we're probably not going to want to trace all the rays. So let's just look at a couple things, and then I'm going to run the VIG command to show you what they do. So here we have the -1 and 1 points defined for all of the field points. Well, the full pupil point is not going to actually get through the system for these off-axis points. So it doesn't make sense to trace all the way out to the coordinates of -1 to 1 on that stop surface for the reference surface, essentially. So that doesn't make a lot of sense. And in terms of the drawing, and by the way, that field point routine, if you're looking for it, it is here in field point set under generate error function. Here, lens drawing conditions is the next thing. That's UOCDRL if you want the command. I'll probably use that later. Here is you can see it's only going to -0.4 and 0.4. If you tried to trace all the way out to the edge, let's make that -1 to 1. You will see in the drawing, we are now blocking rays. They aren't actually getting through. This one is, of course, being blocked by the by the limiting aperture of the limit here of this surface. So it's being checked out by that. Okay, so we're only getting this central ray through, and of course, there's a lot more light getting through than just one ray. We just aren't drawing it that way. So let's go ahead and take a look at the command for VIG. So the kind of output we're going to get is it's going to give field points a configuration, the object coordinates, FBX, FBY, and then for each different point, it will give you where the farthest out that you can go until the checked apertures start blocking it. On axis, it's a little bit greater than 1. That's just due to the ray aiming that we have in here. It's basically that's what you'd want to set to fill the pupil perfectly, and for this exact configuration. And then you can see for 2 and 3, it's been reduced. And that's sort of the point. We're truncating the beams out further. So we are now limiting where we actually trace the rays through the pupil so that we don't bother to trace rays that are going to get blocked. So there are some limitations. So one of them is that the rim ray mode, if you have special apertures, especially central obscurations, it'll work a little bit better than this. Multi-configuration systems, you need to be careful that you have field points set for each configuration, not one field point that happens to apply to all configurations. If you have the case where you have one field point, but it happens to be for all, a field point defined for all configurations, when you run this command, it will set the same vignetting factor for each of the configurations. So if you want different vignetting factors for different configurations, make sure you have field points set for each configuration separately, is what that's saying. This requires meridional symmetry. You are going to need a current field point set. Only checked apertures are taken into account. And then there is some place where you can look up the algorithm that's actually being used. So I think we're ready now to just go ahead and run the command and see what has changed. So when I run Vig, it asks to copy vignetting data to the field point set. We say yes. Or field point set to the drawing fans, absolutely. The max field point, this is just something you're going to want to make sure you trace beyond the actual size of your pupil. So I'm going to go ahead and go with the default there. In terms of where to find this command too, the Vig command, it's in sort of a funny place, support routines vignetting, and then it's under vignetting analysis. I just remember Vig because it's not too hard to remember after you use it a little bit. So you can see now that we've run it here, we've got the FBY, FBX, we've got what our axial point should be to make those rays go through the edge, and then most importantly, here are the vignetting factors for the further ones out. You can see now the if we go to the drawing conditions, you will see DRL. I'll do that this way this time. We have, as you can see, we've now put an extra field point in. Well, for all 3 field points, I should say, we are actually tracing minimum and maximum pupil in a number of different rays. And you can see here as we go out, we're clipping more and more of the beams with these checked surfaces, just as we expect. The other place that we can see the changes is in the field point set. Now the field point set has the vignetting factors appropriately scaling the size of the pupil. So that's essentially how to use this. It's a really useful command when you have vignetted systems. I hope you enjoyed the video.